purpose of this video is to discuss the assembly method required to put the pivot assembly together. Now, the first thing that I'm going to do is I'm going to go ahead and do an insert constraint between this hole and this hole. Doesn't really matter which side I do it to, as long as I put it in there. Now, when you do the math, you realize that the offset is 10.5, so I can go ahead and put in the 10.5 right now. Sorry, 5.5, and apply that. Now, if I look, that thing should be directly in the center, and I have the ability to pivot this. The next constraint that I want to place is the insert constraint that's going to go between here, the insert constraint that's going to go between this piece and the back side of this piece. Now, when I put that in there, you'll see that it's touching, and again, if we do the math, we can see that our offset is 1. So now we've got those two in place. I want to go ahead and use the same insert constraint for the pins. I need to flip that one, and this one should go in normally. Now, the last thing I need to do is I need to do an insert constraint on the bottom of this hole and then the bottom of this piece. So again, I'll do an insert constraint from the bottom of that hole to the bottom of that piece, and that sits in there nice and neatly. So what we are left with is a situation where this piece here can move the other piece. Now, this piece should have some degrees of freedom associated with it, but just for the clarity and the purposes of making sure this looks good, I'm going to go ahead and put an angle constraint between this top face and this top face at 0 degrees. Now, the reason I've done that is so that I can show how this thing works without the piece getting completely crazy and completely wacky the entire time. But that is the method that is used to figure out exactly how to do this. If you want to take a look at a different way of figuring out what those offsets are, I'll go ahead and bring in these two pieces again just to show you another way that you could do that. So here we have our box, and here we have our pivot handle. Let me go ahead and ground this real quick. What I could do is, if I didn't feel like doing the math, I could do a constraint just using my insert constraint. And again, it's going to be from here to here. Either way is fine. And I can apply that and then close. Now what I have is this piece butted up against the other piece. If I go to Tools, Measure Distance, I can click on this face and then click on the opposite face, and it'll show me that it's 11 between those two faces. And if you take a look right here, this is the distance it's actually getting. So knowing that it's 11, I could take 11 divided by 2, which is 5.5, and I can click on this piece and come down here to that insert, and down in this section I can just type 5.5 and hit enter. And what that does is that automatically applies that 5.5 after the fact. So you have two real ways of doing it. You can either do it like this, where you do a little bit of math up front, or you can do it using this method, which just requires a couple of additional steps. From here, what you've got to do is your presentation, a 3D exploded isometric drawing, and your parts list. The main thing to remember is, don't forget, you need those two pins. On page 236 in your book, it's called out as post diameter 6x14 and post diameter 6x26. There's no drawings for those, but they are still necessary for the assembly for this particular piece. If you have any questions, please feel free to email me.